Hello students, I am here with another video from a chapter of class 10th NCERT book, that is Periodic Classification of Elements. Before starting today's video, I would like to tell you all that till now what all things we have discussed in this chapter. So we started this chapter by the need of classification, by the meaning of the word classification. Classification actually means to group the elements. Okay, here we are talking about the elements, so we are grouping these elements. Now why we are grouping these elements? We are grouping these elements just for our ease. We are just avoiding all the kinds of confusion. We are just avoiding the chaos which could take place because of the discovery of several elements. Now in the chemistry, we need to study about the various chemical and the physical properties of each and every element. So to study the various properties of each and every element, there is a need of classification, so that each and every element could also be studied with the help of any idea. Like it could be a common idea, I must say that. So there was a need of classifying these elements, because of which we can easily handle the chemical, the physical properties and the detailed study of these elements. Okay, so there is an idea of this classification. Okay, so the very first beginning of this classification had happened very long ago by the first scientist called Bhanupriya. So he has discovered about the triads, means he has given the means he has classified the very first element, the series of elements, I must say, because there were very less elements at that time, and he has classified all those elements where he saw that there is certain relationship between the mass number, okay, the atomic mass of each and every element. So what is that? What was the relationship? He saw that whenever the atomic mass of different elements are being arranged in the increasing order of their atomic masses, then what is happening? We can say that if we are arranging them, we can find out that the first and the last atomic mass, the average atomic mass was equal to that of the approximately equal to the average atomic mass of the middle element, or the average of the first and the last atomic mass of these elements were approximately equal to the atomic mass of the middle element. Okay, so this was about the Bhanupriya triad. Then the other scientists also started studying, and they saw that there is a relationship between this atomic mass. And then the second scientist, whose name was the Newlands. So this Newland has also found that there is the concept of relationship between the atomic mass of these elements. So he also took the same idea, and he gave his studies, and he found that every eighth element is going to have the same characteristic as that of the first element. So the first to the eighth element's characteristic is always going to repeat, but that also get flopped by this was having certain limitations, like after calcium was not able to classify other elements on the same basis because more and more elements were there. Okay, and then the third scientist, whose name was Mendeleev, who has given the basic idea of this classification regarding the nature of the atomic masses of different elements, as well as he also took the characteristic of the physical and the chemical properties. Okay, so he took this physical and the chemical properties also together with the relationship between the atomic masses. Then he designed a table, and that was almost, it was acceptable during that time, but still it got it got limitations. Why? Because the position of hydrogen was not explained, and there was a wide gap between the two atomic masses of different elements, and there were many more elements which were discovered, and that is why the isotopes were also not given any position in that particular classification. Okay, so then what has happened? There is the next step, the next classification which came into being was the modern periodic table. Okay, this was based upon the modern periodic law, which says that the arrangement if the arrangement of the elements are being done on the basis of atomic number. Now the concept of atomic number has arisen. So this was based upon the atomic number, and then when the atomic number is taking, when the arrangement of the elements are taking place because of the atomic number, then what is there, then we can arrange this particular reaction, or the chemical properties or the physical properties of that element is because of the periodic function. Now what is that periodic function? Periodic function means what is the step, what is the relationship between the atomic mass, atomic number, and the various other constituent, like, because he has taken this atomic number as a concept, because this atomic number gave a wider range of information. Why? Because this atomic number is equal to the number of electrons, and this is also equal to the number of protons, and which is equal to the atomic number. So we can easily study the electronic configuration, we can easily take out the valency, we can easily take out the combining capacity, we can easily take out the number of shells, number of subshells. Okay, so this was very much, this was giving you a wider range of information rather than to take the atomic mass. Okay, so that atomic mass was having the various differences. Okay, what next was done, this atomic number was increasing just by 1. When we were moving from one element to the another element, it was just increased by 1 number. Okay, so that also, the difference was very less. And if difference was very less, there was hardly the possibility of any element to come up. Okay, there was just a possibility of the properties, the isotopes could be developed, and if isotopes were to be developed, then they would have been kept in the same place with this element. Okay, with the present element. Fine. So we have seen the position of the isotopes, that it was fixed with the with the same element where this was classified. Okay, now next thing what we will study, then this modern periodic table has also given certain merits, like the position of the isotopes was fixed. Then it has discovered about the anomalous behavior of the hydrogen also, because this hydrogen could be, sometimes it could behave like alkali metals, as well as it could also behave like non-metals. Okay, so this was also discussed because it has only one electron, which could be either shared or which could be loosed, or even which could be gained also. Okay, so that it could complete its duplet and could be stable. So this was all about the merits of the modern periodic table. Then the electronic configuration was also being done, and this also gave the important properties regarding the physical and the chemical properties studied, could also be studied by seeing this electronic configuration. Next, the separation of metals and non-metals was there in this periodic table, and also the position of the transition elements was also almost fixed, and the properties of these elements were not going to change. Similarly, this was very systematic way of remembering the different properties of these elements. Now children, we have to study about the trends in the modern periodic table. So what is the trend, and why we are studying this trend in the modern periodic table? The trend because there is certain way by which we could increase the there is certain connection between the different properties of this periodic table. Okay, the components of periodic table. So the properties which we need to study here, the trends in the properties, or the properties of this modern periodic table, in which we can observe a particular trend. Trend means a particular pattern we can observe, a decreasing pattern or increasing pattern. Okay, we could also even observe the first it is increasing, then decreasing. There is a definite pattern in each and every property of this modern periodic table. Okay, so what are these patterns? We can say that the first trend we will study about, that would be under this atomic, it could in the atomic size. Okay, that could be in atomic size, it could be in valency. Okay, then it could be, if it is in valency, then it could be in the ionization capacity, metallic character. Okay, non-metallic character, So that could be in metallic character and non-metallic feature. Okay, so that could be in different other forms. That these could be these are the very less properties upon which we can study the trends, but there could be several other properties where we could study the trends, where we could study the pattern. So what do you mean by trends? Trends means pattern. There is a particular pattern in the increase and decrease of these all features of periodic table. Okay, now we move on to the first feature, that is the very first feature or regarding the increase or the decrease we have to study is of the atomic size. Now what does this say? The trends, why we are discussing this trends? Because we have studied about the main feature of the long form of periodic table. And what is this long form of periodic table? I think you all have understood now. This modern periodic table is also known as the long form of periodic table. Okay, so it is also known as the long form of periodic table. Please remember why this is a long form, because 118 elements are discovered at that time, and this got all arranged, each and every element got arranged in it. Okay, and this was very much easier for the different properties to be studied. Now what this makes very easier for all the properties, all the elements to be studied. So we have learned about the main features of long form of periodic table in the previous section, and previous section means just now we have studied. Okay, now here in which you can, it consists of groups and the periods. This we have already understood. Okay, because this modern periodic table has two columns. One is the vertical columns, and these were known as the 18 groups, and the horizontal rows, all these were known as the 7 periods. Okay, so it consists of two features. In a given group, the number of shells are increasing. In a given group means when we are moving down the group, then the shells are increasing, okay, so these number of shells are increasing when we are moving down the group. Okay, next is that we can also understand that the number of valence electrons in the same elements of all is same in each and every group. So if we talk about the first group, the number of electrons are same. First group element will have 1 electron in the valence shell. Second group element would have, all the elements would have 2 electrons in the valence shell. Similarly, the third group element would have 3 electrons in the valence shell. Okay. However, the valence electrons are present in the higher shells, which are further away from the nucleus. Okay. In other views, it decreases the force of attraction between the outermost shell and the nucleus when we move down a group. Okay. Next thing is that in a given period, the nuclear charge of a number of the valence electrons of particular shell increases from right to left to right. This increases the force of attraction between the valence electrons and the nucleus, and if we move across a period, okay, from left to right, just above given changes would affect the properties which show a gradual variation in the groups, fine, and the periods. So and it is repeated themselves after a certain interval of atomic number. This is known as periodic properties. Now what is the periodic property? Periodic property means that all those properties which are related with this atomic size, which is related with this atomic configuration, and it is also related with the position of the electron, children. Okay, so that is why it is known as these are the periodic properties, because this was changing. This also was following a trend in the periodic table. Okay, so what kind of trend it is being observed, we will just see one by one. So the first property, the first trend we will see about is of atomic size. Okay, we will discuss about the atomic size, the trend in the atomic size. Okay, children. So we will just discuss about the trends in the atomic size. Fine. So what is the trend in the atomic size, children? So here the atomic size is the distance between the, what is this, how is this atomic size or the size of an atom is considered? We always consider the atomic size by the distance between the center of the nucleus and the outermost shell of an isolated atom. So how we can understand what is the shape, what is the size of a particular atom? The distance between the center of the nucleus. Okay, for example, if we draw an atom, So this one is the nucleus. The distance from the center of the nucleus and the outermost electron, this is said to be as the atomic size. Okay. Now if there are many shells, so we could say that from the center of the nucleus till the outermost shell. So this gives us the atomic radius. This gives the atomic radius, or this also is equal to the atomic size. Okay. So we have to calculate this atomic size from the center of the nucleus, from the center till the outermost electron. Okay, outermost electron. Fine. Now what we need to study is, we will have to study the trend in this atomic size. How is this atomic size going to vary if we are moving from down the group or we are moving across a period? Okay. Now here what does it says? It is also known as to be the atomic radius. Now as I told you that it is also known as the atomic radius. So how would we measure this atomic size? We measure this atomic size. What is this atomic size? This is equal to the, this is equal to what? This is just equal to the outermost, the center of the nucleus with the outermost electrons. Okay. So where is this, how is this atomic size getting, I mean, how we will measure it? We can measure it by the center of nucleus of an atom to the outermost outer shell electron, or outer shell. Okay, till outer shell. Suppose that this is the center, from here till the outer shell we are measuring this. This is also known as atomic radius. Okay. Now what is this atomic radius? It is just the measure of the center of the nucleus till the valence shell. Okay. The size from the nucleus till the valence shell. Now next thing what is there? The next thing which we have to study is the property. How is the property getting measured? How the property is getting changed, or the, I mean, how is this this atomic size getting increased or decreased, or how it is forming the trend in the periodic table. Fine. So it is measured in picometers, that is equal to 10 to the power minus 12 meters. It is measured in picometer, it is written as P and M, PM. Then it is measured and it is equal to 10 to the power minus 12 meters. 1 picometer is equal to 10 to the power minus 12 meters. Okay, it is such a smaller unit, and we can easily measure this atomic size in this picometer, children. Okay. Now the next thing is that the atomic size is very important property of the atoms, because it is related with the many properties. Now what is the variation in this atomic size in the periodic table? The size of an atom decreases, the atom decreases from left to right in a period. Okay, the size of an atom decreases from left to right in a period, but increase from top to bottom in a group. For example, if the atomic radius of an element of the second period and the group 1, it is like, how would you calculate this? Let us find out with an example. So what is the trend of the atomic size in the group as well as in the period? We will discuss this. What is the trend of this atomic size? So what is the trend? The trend of this atomic size is what is the trend? Trend says that it increases from top to bottom. It increases from top to bottom in a group, whereas it is going to, and across a period what happens? Atomic size of it is going to decrease from left to right, and it is going to decrease from left to right in a period. Okay, when we move this side it decreases, and when we move this side down the group it is going to increase. Now how this is happening, let's see. So we need to calculate the different, we have to see the atomic number. If it is having 3 atomic number, 4 atomic number, then it has different atomic numbers like 5, 6, 7 and 8 and 9. Okay, we'll just write down the size of the radius. Here it is given as lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So these are the groups. We are moving from left to right. Okay, we are moving from left to right in a period. Okay, so the third period, 4th, 5th, 6th, 7th, 8th and 9. Okay, 3, 4, 5, 6, 7, 8, 9. This is lithium, this is carbon, this is nitrogen, this is 6 is, okay, 4 is, sorry, this is beryllium. Okay, then next is this is boron. This is because this is atomic number, boron, carbon, nitrogen, oxygen and fluorine. Fine. So lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Now what else we will see? We will just look at the radius. This is 134 picometer. Okay, then next is, the next one is 90 picometer. Okay, it is 90 picometer. Then after that it is 82 picometers. The second one is 90. Fine. Then next is 82 picometer. This is 77. This is 75. This is 73 and this is 72. Fine. So if we say that this is this much big, this large circle, then small, then small, then small, small, small and small. Okay, so this goes on decreasing when we move across across a period. Okay, when we move across from left to right in a period, this is 3rd, 4th, 5th, 6th, 7th, 8th, 9th, all these are the group numbers. And when we talk about when we are moving across a period, it is going to decrease, children. Okay, so why this is happening? In a period, the atomic mass, atomic number and therefore the positive charge, atomic number is going to increase. Okay, therefore the positive charge of the nucleus also increases gradually. Now what is the reason regarding this? The reason regarding this is that when we are moving across a period, then what happens? The atomic number also gets increased. When the atomic number is increasing, it means its positive charge is also increasing. Okay, when its positive charge is increasing, it means that the nucleus also is in, the positive charge in the nucleus is increasing. Then as a result, the electrons are getting attracted more strongly and they come closer to the nucleus. So what has happened here? In this case, when we are moving across a period, it is going to increase this the nuclear charge. The atomic number is increasing. The atomic number is increasing when we are moving from left to right. Okay, now what is happening? If atomic number is increasing, it means that the nuclear charge also is increasing. Okay, nuclear charge also increasing. It increases nuclear charge. Because of the increase in the nuclear charge, what is happening? It is going to get a greater force of attraction. Greater force of attraction is being done from the innermost shell to the outermost shell. It is going to attract the electrons because this is positively charged and the outermost shells are negatively charged. It is going to attract the nucleus, attract the electrons. That is why it shrinks. The structure of the atom shrinks because it decreases. That is why it decreases. So please understand that what is the meaning of the word effective nuclear charge. So what is this charge? Nuclear charge, or simply if we say nuclear, effective nuclear charge. What is this nuclear charge? Nuclear charge means it is a force of attraction. It is a force of attraction which is arising from the nucleus till the electrons. Okay, till the electrons. Fine. So what is this effective nuclear charge? This is just the way of attracting from the nucleus. Because it is positively charged, it is going to attract all the negatively charged electrons towards the center, because of which the size of the atom gets reduced. So why it is getting reduced? Because as we are moving from left to right in a period, what is happening? The atomic number is increasing, 3, 4, 5, 6, 7, 8 and 9. So the effective nuclear charge is also increasing. Here the charge was less, the electrons were easily going to be rounded off. Here similarly, here also the atomic size has decreased. Why? Because the electrons were being attracted towards this towards the center of the element. Okay, similarly next also was what has happened, it has more short, this has shrunken. Why this has shrunken? Because the effective nuclear charge is increasing because of the increased atomic number. Okay, so once the atomic number is increasing, which is equal to the number of protons, if number of protons are increasing, it means positive charge is increasing from the center, and it is going to attract the electrons which is present, which is revolving in the outermost shell. So as a result, what happens, the size of the atom gets reduced. So that is why when we move across a period, the atomic size decreases, and when we move down the group, it is going to increase. Now why it is going to increase? Let's find out. So when we are moving down the group, then what is happening? The one more shell is also added. Okay, one more shell is also added. Fine. So once this is getting added up, then what has happened? It is going to increase. It is going to increase the one more shell in it, and what happens? Because it is increasing its shell, the effective nuclear charge is not going to be affected. Okay, that is why it remained in a larger area. Now it is going to be increased in an area. Okay, now however, when we move down a group, then what happens? A new shell is added. Please remember this. Here the same shell is there, only the effective charges are increasing. So what is happening? All the electrons are getting attracted by the center positive charge. But when we are moving down the group, what is happening? One new shell is added up. So once a new shell is added up, then what happens? The electrons are moving away from the nucleus, because already the size has increased, because one shell is extra being added to it. Now once the new shell is being added, then the positive charge which is present was less. So the electrons are not getting that much attraction from the center of the nucleus. So that is why what will happen? It is not going to, this is not going to affect the size of the nucleus, and the size of the nucleus goes on increasing when we move down the group. Okay, so the reason is that the electrons moves away from the nucleus as the size increases from top to bottom. Okay, now we'll take one example regarding this also. So I think this might be clear to you all, that when we move across a period, this atomic size is getting reduced, this decreases because of the effective nuclear charge is increasing. Now if we are taking the example of atomic number 3, we are moving down the group. Okay, please remember 3, then 11, then 19, then 37, 55. Okay, now what is this? This is lithium, this is sodium, this is potassium, this is rubidium, and 55 means it is cesium, Cs. Okay, now what is the atomic radius? It is 134, this is 154, this is 196, then this is 211, this is 225. So what will happen? The smaller increase and increased. Okay, so this is continuously getting increased. Fine. What will happen? Why this is getting increased? Because the effective nuclear charge is getting reduced, because one new shell is added. New shell is added when we move down the group. Okay, that is why the size increases. The size increases because once the new shell is added, suppose that this was there, one new shell is added here. Okay, so if new shell is added over here, for example, if you say 3 is there, then how would you configure this? 2 and 1, 3, then K and L. Similarly 2, 8 to 10, 1, 11, K, L, M shell, 3 shells are there. Similarly here also 2, 8, 10, 9, 19. Okay, 8 and 1. Okay, like this, 9 cannot be there. So K, L, M, N, one more shell is added. Similarly, the shell number is increasing when we are moving down the group. If you are going to configure this, you will be easily understanding. So if the new shell is added up, then what is happening here? Please understand this. The increase in the atomic, this plus positive charge is not increasing. This is going to the atomic number is 3 only. So here 2 shells are there. So 2 shells here, the effective nuclear charge is not able to attract the electrons which are revolving. Okay, the more and more charge is present, more and more charge is there in the center. This is not going to affect the electrons which are revolving because a new shell is added here. So the distance from the center and the nucleus, from the center of the nucleus and electrons which are revolving is increased. So the size of the atom gets reduced. Okay, so the size of atom gets increased, not reduced. Okay, so it get increased. So please remember that what is happening when we are moving down the group, the size of the atom is increasing just because of the addition of the new shell, and the distance from the center and the nucleus, center of the nucleus and the outermost electron is getting reduced. So the effective nuclear charge is not going to attract much more electrons from the center. That is why the size remains larger when we are moving down the group. Okay, so this was all about the trend of the atomic size in the modern periodic table. Okay, so what we have studied is the first trend, that is about atomic size, and it is measured in picometers, and which we take the distance from the center of the nucleus till the outermost electrons, outermost shell I must rather say. Then we have seen that when we are moving across a period, the atomic size is not going to be, it is going to be decreased, and when we are moving down the group, it gets increased up because of the lesser effective nuclear charge as one more shell is added in it. So just remember how to configure all these. You can easily understand if you are doing configuration, you can easily find out that one more shell is added up. Okay, so just remember the groups and you can easily prove all these, this trend in both the cases, in the period as well as in the group. Okay, so that is all about today's video, children. I will meet you all in the next video with the next topic to be discussed. That would again be a trends in the periodic table. Okay, so I have discussed only the first trend. I'll discuss more trends in the next class. So that's all for today's video. I will meet you all in the next video.